Refraction of light. If you put straw or pencil in water, they appear to bend at the surface. Do you know why this happens? This is due to the phenomenon called refraction of light. When light travels obliquely, from one transparent medium into another, there is change in direction of light, and it gets bent. This bending of light is called refraction of light. The light bends because the speed of light changes as it passes from one medium to another. Speed of light is different in different optical mediums. In air, it is equal to 3 multiplied by 10 raised to the power of 8 meter per second, optically rarer medium. In water, it is equal to 2.25 multiplied by 10 raised to the power of 8 meter per second, optically denser medium. Hence we see, when light passes from air to water, its speed slows down, and the light rays are bent, hence the pencil and straw appear to be bent. Refraction of light is bending of light. But this bending varies when light passes from one medium to another. Let us learn some important rules, followed by light rays, during refraction. When light travels from a rarer medium to a denser medium, it bends towards the normal. When light travels from a denser medium to a rarer medium, it bends away from the normal. The ray of light, which is incident normally on the surface, separating the two media, passes undeviated. Now let us see the ray diagram showing the refraction of light. A, B, is the boundary or surface of separation between two mediums. That is, medium 1 and medium 2. When a ray of light falls on this surface, it gets refracted. Incident ray. PQ ray, falling on the boundary of the mediums, is called incident ray. Refracted ray. QR ray, moving away from the boundary after refraction, is refracted ray. Normal. Line SQ, which is perpendicular to the boundary at the point of incidence. Angle of incidence. The angle between incident ray and normal is angle of incidence. Angle of refraction. The angle between refracted ray and normal is angle of refraction. Let us understand what is reflection of light. It is the phenomenon of bouncing back of light after striking a smooth polished surface. As you can see in the figure, light ray falling on the mirror get reflected after striking the mirror. Let us learn some important terms related to reflection of light. Incident ray. The ray of light falling on the surface. Reflected ray. The incident ray bouncing back in the same medium after striking the reflecting surface. Point of incidence, P. The point of the mirror surface, where incident ray strikes, and reflected ray bounces off. Normal. It is the line drawn perpendicular to the reflecting surface at the point of incidence. Angle of incidence, I. Angle between incident ray and normal. Angle of reflection, R. Angle between normal and reflected ray. Laws of reflection of light. Reflection of light from a reflecting surface takes place according to definite laws. These are known as laws of reflection. First law says that the incident ray, the reflected ray, and the normal to the mirror at the point of incidence all lie in the same plane. And according to second law, the angle of incidence is equal to the angle of reflection. Light introduction. You see different objects around you. What enables you to see these objects? It is light. Light is a form of energy, which helps us to see objects. The sources of light can be natural like sun and stars, and also artificial, or man-made like candle, bulb, lamp. Laws of refraction. Refraction of light from the refracting surface takes place according to definite laws. These are known as laws of refraction. There are two laws of refraction. 1. First law says the incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane. 2. Second law says for any two given pair of media, the ratio of the sine of the angle of incidence, I, to the sine of the angle of refraction r, is constant. This constant is called the refractive index of the second medium, with respect to the first medium. It is represented by 1 μ2, or 1 n2. That is, sin I, by sin r, which is equal to 1 μ2, or 1 n2. This law is called Snell's law.